All right, so the next function that we're going to talk about is absolute value and square root graphs. So we're going to learn how to graph both of those. So far we have done linear, which is like mx plus b. And so this whole semester kind of is just talking about the different types of functions, how to graph them, how to solve them, things like that. So an absolute value makes a v. And it looks like it has the two vertical bars in between. Anytime that you have the two vertical bars, that means everything inside is going to end up being positive. So even if you have a negative in there, it's going to end up being positive. So the domain is this is called the parent function. Parent function just means like the very simplest form. That means no transformations at all. The domain is from negative infinity to positive infinity. And then my range, it starts at 0 and it goes to positive infinity. And you have a bracket because it is defined at 0, 0. Sometimes you'll see questions that say, like, what is the end behavior? And that just means, like, what is the graph doing to the left and to the right? So this little fancy thing right here, all that this means is as x is going to the left, so as x is approaching, I can write, as x is approaching negative infinity, so negative infinity is out here. As x is going that way, what is y doing? So as x is going to negative infinity, what is my y doing? It's going to what? Anyone have an idea? It's going up, right? So it would be positive infinity. So it's just saying as x goes to the left, what is y doing? Y is going up. And so up would be positive infinity. If something was going down, it would be negative infinity. Then my end behavior for the right, so as x is approaching positive infinity, so this is to the right, my y is also going up. So then the y is going to positive infinity. And so these f of x's, they represent y. What is my y doing? And so we teach end behavior because you'll see it sometimes. I've seen it on the SAT once before. I don't see it very often, but you do talk a lot about end behavior once you get to pre-cal. And then when you start talking about limits when you get to calculus. So we're going to try to get you accustomed to that. So the definition of an absolute value, so inside, it's always positive. So if x is inside, if x is positive, if it's 0 inside, then x equals 0. And then negative x if x is negative. So anything inside of there, the absolute value just means that it's going to end up being positive. It's the distance that the number is from 0. Distances are always positive. You can't walk a negative distance. So even when you're even if you're walking backwards, you're still going a positive distance. So you could walk around that track backwards an entire lap, but you would still be going a quarter of a mile. So for all of these, if you're finding the absolute value, it's just the number inside. So it would be 5, 2, 0, and then 8.1. Very simple. Okay, we talked a little bit about transformations in the very first unit, if you can kind of recall. So we have this function right here. Remember that if you have a positive or negative in front of the a, so if I have a positive or a negative, if it's positive, do I write any transformation? If it's just a positive a? No, but if it's negative, what do I say? Reflects the x-axis. Yes, perfect. Oh, we can't. So whenever you have a negative sign in front of the a, we say that it reflects the x-axis. Then the a itself, that is a vertical stretch or compression. Vertical stretch or compression. How do I know the difference? Like, when is it stretched? opposite. So if it stretches when it's bigger than 1, it compresses whenever it's less than 1. So any fraction that's less than 1. The H tells me what? Left or right. So L or R. And then the K tells me up or down. Good. So just a little refresher. K is up or down. So if we look at number 5, it says what transformations occurred, and we're going to graph it. So there's no negative sign, so I just leave that be. The 2 tells me what? Vertical stretch by 2. That is also the slope. So whenever I plot my vertex in the B part, when I plot my vertex, I'm going to use that number A, like whatever that is, 2. 2 is going to be my slope. So vertical stretch by 2, or by a factor of 2. Then the 4 tells me what? Left 4, and the 2, down 2. Good. So I'm going to start at 0, 0. To plot my vertex, or to plot that center point of the V in my absolute value, I'm going to go left 4, I'm going to go down 2. Since it is a positive, that means that the V is going to be facing up, and we'll see another example where the V will be facing down, but it's facing up, and the slope is 2. So I'm going to go up 2 over 1 on each side. So you're doing it twice. So it creates a V, then I connect my dots. Like this. You only need to go up a few times, as many as you want. Okay, so try graphing number 6. So tell me the transformations and then graphing it. So the negative sign means it reflects the x-axis. It goes to the right 1 unit, and then there's a vertical compression by 1/2. So you plot your vertex, which means you just go right 1. You don't go up or down any. And then the slope of 1/2, since it's reflected, you're going to go down 1, and then to the right and the left 2. So going down 1 over 2 on each side. You just need to do it twice, maybe 2 or 3 times. Then you can connect the dots. Oops. So the square root parent function is just f of x equals the square root of x. And so it makes kind of like a little, kind of looks like an exponential graph almost. But it starts at 0, 0. And there's nothing to the left of it. Because when you take the square root of a negative number, you end up getting an imaginary number, which we haven't even talked about. So there's nothing out here because you're not ever going to have a negative square root. And so the restrictions are when x is greater than or equal to 0. That's the restriction. So you can't have anything negative. No negatives. No negatives under the square root, I should say. Because you could have negative square root of x, which just means it's going to flip or reflect the x-axis. So that is okay, but you can't have this. That's not okay. So what would my domain be in this? Where does it start? What x value? 0. So bracket 0 to positive infinity. And then what about the range? Where does it start? It also starts at 0 to positive infinity. Now my end behavior, so as x is going to the left, so all the way out here, where does my y stop? At 0. So it stops right here. It doesn't go out anywhere to the left. But as x is going to the right, what is happening to my y? It's going up, so it's positive infinity. So you have to think about left and right, up and down. Transformations are exactly the same for a square root function, so I'm not going to rewrite them, but you're still going to say reflects the x-axis, vertical stretch compression, left, right, up or down. So if we look at number 7, I'm going to scroll down a little bit so that we have more room. If we look at number 7, what would my transformations be? Left 5 and down 6. So left 5, down 6, there's no reflection, there's no vertical stretch or compression. So I'm going to start at 0, 0, and then I'm going to go left 5, and I'm going to go down 6, and that is where my dot is going to be. Now, whenever you're graphing a square root function, there's not really a slope because it's going to be increasing or decreasing exponentially. So my suggestion is to choose maybe 1 or 2 points that make this right here a nice number. Does that kind of make sense? Like, think about what are perfect squares. So you've got 4, 9, 16, 25. Like, what x value can go in there to make that a nice number? So if I want to keep graphing it, right now I'm at x equals -5. So -5 plus 5 ends up being 0. So that one ends up being the square root of 0. What is another x value that I could put in that's going to maybe make it maybe the square root of 4? So what could this be so that that number plus 5 equals 4? Does that make sense? X equals -1. -1. So when x equals -1, so the square root of -1 plus 5 minus 6 gives me the square root of 4 minus 6. So that gives me 2 minus 6, which gives me -4. So I have an ordered pair at -1, -4. And I will only make you plot 2 points, and then you can just connect the dots, and you kind of know what shape it's going to make. So at -1, 1, 2, 3, 4, here's my next point, and then just connect the dots, this, and I'll let you be done. So my domain, if I'm reading it from left to right, where does it start? What x value? -5 to what? Positive infinity. Then my range, if I'm starting from the bottom and I'm going to the top, what y value does it start at? -6 to positive infinity. So domain and range are pretty easy because it always starts at your vertex, which is this first point right here, kind of like what the transformation is. Okay, try number 8. The vertical stretch is not going to make a difference when you're plugging in a point. Basically, for your second point, you're just going to want to think, what x value is going to make this a nice number? Okay, so for this one, we have a negative, so it reflects the x-axis. Vertical stretch by 2. Right 2, up 5. So my first step is starting at 0, 0. I go right 2, up 5. That becomes my vertex, or my starting point. I forgot to mention this in the last example, but if you have some sort of vertical stretch, or even if you don't, the first point that you can plot is I could go down 2 over 1. So that's considered like your slope. So if I go down 2 over 1, that is one point that I can plot. On number 7, the slope was technically 1, so whenever I had my point, I could have gone up 1 over 1 and then drawn. But I want you to plot 2 points. So the first one, down 2 over 1. Then the second one, I chose x to equal 6, because when x equals 6, that made the square root of 4. So trying to get to square root of 4 is usually your best option. So when x equals 6, you end up solving it and you end up getting your y value is 1. So you have an ordered pair at 6, 1. And then you connect the dots. Notice that it's now going to negative infinity because of the reflection of the x-axis. So instead of going up and to the right, it's like you flipped it. So reflects the x-axis just means that you flipped. Now it's going to be pointing downwards. But when you connect the dots, you'll see that. So my domain, it starts at 2, goes to positive infinity. My range now goes from negative infinity and it stops, and it never gets higher than y equals 5. So for absolute value inequalities, the hardest part is knowing whether to dash or solid line. And so that's, remember that if you have a less than or greater than, then it's dashed. Then if it's greater than, less than, or equal to, then you use a solid line. If you have all less thans, then you shade below. And then if you have greater thans, then you shade above. There is really no uncertainty with these. You can always do the 0, 0 test if you are unsure. However, this one is super easy because you either shade above or below. Because absolute value graphs always make a V. They're never tilted or anything like that. So you either shade above or below. So the graph for number 1, it's going to be a dashed line, and it's y is less than the absolute value of x. So I start at 0, 0, and I dash. The slope is just 1, so it's up 1 over 1. Like this. It is a less than, so do I shade above or below? For a less than. Below. I'm going to shade all the stuff below. So for number 2, you have a negative sign, so it reflects the x-axis. Vertical stretch by 3. Left 5, up 4. So you start at 0, 0, go up 5, left 4. Then, since it's reflecting, you're going to go down 3 over 1. Down 3 over 1, so it'll be facing downward. Then it is a greater than inequality, so I'm going to shade above. Okay, last one would be a vertical, what, stretch or compression? Compression by 1/3. And then it would be down 7. There would be no left or right. So I start at 0, 0, I go down 7. It's facing upward because there's no reflection, so I'm going to go up 1 over 3 on either side. Will it be a dashed or solid line? Dashed. And do I shade above or below? Above. So that is all for inequalities for absolute values.